કેમ છો દોસ્તો? આપણે વેક્ટરને આગળ લઈ જઈશું. અગેન કન્સેપ્ટ તમને ખબર જ છે, બરાબર? આપણે એમાં થોડા એક્ઝામ્પલ્સ છે, આજે હવે આપણે એડિશન કરીશું. આજે તમને થોડું રિયલાઇઝ થશે કે વેક્ટર છે એ ફિઝિક્સ કરતાં મેથ્સનું વેક્ટર છે એ કેવું છે કે થોડું ડિફિકલ્ટ. ઓકે, so let us start with the position vector. So this is position vector. Position vector શું બતાવશે? So it represents the position of the object with reference to origin. આપણું origin છે સ્પેસમાં અને આ પોઈન્ટ P એની પોઝિશન કોણ બતાવશે? પોઝિશન વેક્ટર R. So point O is fixed as the origin in space. Okay, so P any point OP is called position vector P with respect to O. તો કોઈ પણ ઓબ્જેક્ટ છે એની પોઝિશન આપણે વિથ રિસ્પેક્ટ ટુ ઓરિજિન બતાવશું, એને આપણે શું સ્મોલ નામ આપશું? સો R is position vector. Okay, so instead of one point, suppose there are 2 points. Okay, so we can say vector AB. So vector A, તો હવે આ A point છે that is also in space. તો એ પણ એક પોઝિશન બતાવશે. So it represents position with reference to origin. તો આ A point છે એ વેક્ટર, that is any position કહીએ તો કે OA is position of A, એને કહેવાય A. OB, so that is position vector B. તો આ શું થયું? position vector A, position vector B. So we know the position vector A and B. Now find out vector AB. Find out vector AB. So to find out the vector, okay, suppose AB in terms of position vector AB. So A is position vector of A, B is position vector of B. So now to find out AB, use triangular law of vector addition. So I can say OA plus AB is equal to OB. So OA plus AB is equal to OB. So AB is equal to OB minus OA. OB minus OA, or I can write B minus A. So simple. Final position, so that is initial point and terminal point. So terminal point minus initial point, or B minus A. So position vector of B minus position vector of A. Position vector of head minus position vector of tail. So AB, B minus A, simple. Okay, so now, so first we have defined position vector A, now vector AB. Now we can divide this vector into 2 parts. Okay, so I can divide it internally as well as externally. So position vector of dividing point. So now consider vector AB. So position vector OA, so that is A, position vector OB, so that is B. Now divide vector AB into 2 parts, okay, such that we divide in the ratio of M is to N. So ultimately we are dividing the line AB into 2 parts in the ratio of M into N. So directly we can use the same formula. It means we can find the position vector OC, or you can say C, by using the straight line equation. Okay, so internally AB divided in the ratio of M is to N. So the equation is, so in case of straight line, so that is MB plus NA divided by M plus N. So OB is equal to MB, but here B is not magnitude, it's a vector. Okay, plus NA, A is the vector, divided by M plus N. So M and N both are scalar. So you can find position vector OC by using this formula. So if it is divide internally, so if it divide externally, so you can see point C. So now again I can write M and N. So here I can write M, here I can write N. Okay, so M and N. So same M, B, N, A, but instead of plus, now I have to use minus. Okay, so external division, same in the ratio of M is to N. So I can write MB minus NA, MB minus NA upon M minus A. So if it divide externally, then minus. If it divide internally, then plus. So this formula is same as division of straight line into 2 parts in the ratio of m is to n, or I can say in the ratio of lambda is to 1. So here lambda b minus 1 upon lambda minus 1. Okay, so now we can use the same formula which we have used in straight line. Okay, so now just for information, point vector of midpoint AB. So for midpoint directly we can write a plus b by 2. If a and B, A, B, C are the position vector of vertices of triangle. Okay, then position vector of centroid. So we know A plus B plus C by 3. Okay, so if it is A, B, C, X, Y, Z, then X1 plus X2 plus X3 by 3, a Y1 plus Y2 plus Y3 by 3. Similarly, A plus B plus C by D. So if A, B, C, D are position vector of vertices of tetrahedron, then position vector of centroid, that is A plus C plus C plus D by 4. This is just for formation. So whenever we solve the example, you will understand it easily. So let us start with the example. So first example, the position vector of a point A plus 2B and A. So A is also a vector. Divide AB in the ratio of 2 is to 1. Suppose directly let us see the figure. Okay, so position vector of point A, so A is A plus 2B and another vector, so that is OC, you can say A. Divide AB in the ratio of 2 is to 3. Then find the position vector of B. So find the position vector of B. So assume position vector of B is X. Now I can use OC. OC is equal to OC is equal to 2 into X plus 3 into A plus 2B upon 2 plus 3. So OC is equal to, so I can write here A. So 5A is equal to 2X plus 3A plus 6B. So 2X is equal to 5A minus 3A minus 6B. So I can say 2A minus 6B. So answer is X is equal to A minus 3B. So A minus 3. Okay. So next example. So now one more. If D, E and F are midpoint of the side BC, CA and AB respectively. So I can say A, E and C. So D is the midpoint of BC. So you can say it is midpoint. You can use separate color. D is the midpoint of BC. CA. So D, E and AB. So that is F. You can join this also if it is required, but at presently it is not required. So respectively of triangle, and O is any point. O is any point. So I can consider any point. Suppose here I can consider any point. Then OA plus OB. So I can join OA, OB and OC. Similarly, I can join OD. So O is the point. So OD is this one. OD, OE and OF. So I have to find OA plus OB plus OC is equal to OD plus OE, OD plus OE plus EF. Oh, sorry, OF. So I have to find the relation. Okay. So now D is the midpoint of BC and I have to find the relation between OA, OB, OC, OD. So it means first I have to focus on point D. Okay. So OB and OC, point D is midpoint. So position vector of D, so that is OD. OD is equal to OB plus OC divided by 2. It means now I can write OB plus OC is equal to 2 times OD. Similarly, for here also I can write, so OC plus OA, so OC plus OA is equal to 2 times OE. OA plus OB is equal to OF, 2 times OF. Okay, so now add equation 1, 2 and 3. So I will get 2 times OB plus OB, 2 times OC plus 2 times OA, and here is again 2 times OD plus OE plus OF. So now it is proved OA plus OB plus OC is equal to. So here trick is you want to find relation between OB and OD. So focus on this part and similarly apply to 3 sides. Clear? So in vectors, okay, so you where to start, so that depends on the situation. Okay, so there is no ready-made formula. So find the position vector of points which divide the joining of point A 2A minus 3B and B 2A minus 3B. So first 2A minus 3B, second 3A minus 2B internally and externally in the ratio of 2:1. So now it is given directly point A, point B and position vector C. So divide in the ratio of 2:1. For internal division I can write OC is equal to 2 into B. So 2 into B, B is 3A minus 2B plus 1 into A, so 1 into 2A minus 3B upon 2 plus 1. Okay. So answer is 2, 6 plus 2, so that is 8A minus 4B minus 3B, so minus 7B divided by 3, so 1 upon 3. So that is OC. So 1 by 3, 8A minus 7B. Okay, so this is for internal division. Sorry, internal division. For external division, similarly I can write, suppose point C is somewhere over here and divide it into 2:1. Divide it into 2:1. So similarly, instead of plus, I have to consider minus. Okay, so now 2 into 6A minus 2A, so that is 4A minus 4B plus 3B, so that is minus B upon 2 minus 1, so that is 1. Okay, so same ratio, just instead of plus here you have to consider minus, instead of plus I have to consider minus. So here it is minus, here it is minus, so you will get 4A minus B upon 1, so that is 4A minus. So first internal division, second that is external division. So let us start new problem. The position vector of vertices A, B and C. I can say position vector of vertices A, B and C. A, B and I minus j minus 3k, 2I plus j minus 2k, minus 5I plus 2j minus respective. The length of the bisector AD or BAC. So I can consider suppose angle BAC and bisector. Divide this angle to two equal part. Okay, so point D, angle theta, an angle. So what is the ratio of BD and DC? So that we don't know. So where D is the segment of BC. So find the length AD, the length of bisector AD. So to find the length AD, first we have to find position vector of point D. So to find the position vector of point D, okay, we should know the relation between BD and DC, because we know the coordinates of B and C. Okay, so relation between BD and DC, so that is equal to, from the geometry we know, AB is to AC. So BD is to DC is equal to AB is to AC. It means first find out AB and then find out AC. So let me find out AB. So AB is equal to B minus A. So B minus A. So 2 minus 1. So that is I. B minus A. 1 minus minus plus. So that is 2J. Minus 2K plus 3K. So that is K. So that is AB is equal to under root 1 plus 4 plus 1 under root 6. Similarly, find out AC. So AC is equal to minus 5 minus 1 minus 6I plus 2J minus minus plus J, so plus 3J, minus 6 plus 3 minus 3K. So under root 36 plus 9 plus 9. Under root 36 plus 9 plus 9. So 18. 9 plus 9, 18. So 18 threes are under root 54. Under root 54. So 9 into 6. So I can say 3 root 6. 3 root 6. So this ratio. So 1 ABD. That is AB. So root 6. And this ratio is 3. Sorry. 3 root 6. Okay, so root 6 and 3 root 6. So now if you want to find position vector D, then position vector D, OD is equal to, so if we take the ratio, okay, so here it is root 6 and here it is 3 root 6. So I can say root 6 into root 6 into C. So position vector C minus 5I plus 2J minus 6K plus 3 root 6 into B. So position vector B. So 2I plus J minus 2K divided by root 6 plus 3 root 6. So 3 plus 1. Okay, it means I can remove root 6, root 6, root 6. So now final answer. So here I can say minus 5I plus 6I. So I can say I. 2J, 3J, 2J plus 3J. So that is 5J minus 6K. 3 into 6 minus 6K. So minus 6K minus 6K minus 12K divided by 4. So 1 upon 4. So this is position vector OD. So OD is equal to 1 upon 4 I plus 5J minus 12K. Okay, but we have to find length of the bisector. So length of the bisector is, so length of the bisector is, so length is equal to, suppose you can say length is equal to under root. Okay, so length AD, so that is OD minus OA. So I can remove. So length AD. So AD is equal to OD minus OA. So OD that is 1 by 4 I plus 5J minus 12K minus OA is I minus j minus 3k. Okay, so now to simplify it, divide it by 4. So here multiply it by 4. So you will get I minus 4i. So I can say minus 3i. Okay, minus 3i. So 5j minus minus plus 4j. So 5j plus 4j, I can say 9j minus 12k. So minus 12k minus minus plus 12k. So I can say 24k. Okay. So 4 common, 3 common. So I can say 3 by 4. 3 by 4. 3 common. So inside I can write minus I plus 3j plus 8k. Okay. So 3 by 4. So I can say the answer should be 3 by 4 root 10. So next example, the median AD of triangle ABC is bisected at E. So triangle ABC, median AD. So median, it means D is the midpoint, median AD. D is the midpoint. Median AD is bisected at E. BE meets SE in F. I can use another color. Okay. So bisected at point E. So point E. So that is again bisected. Here I can say 1, 1 and BE. So point E. So BE meets AC in point F at point F. So here it is F. So AF and FC equal to. So we want to find AF and FC. So assume ratio AF is lambda, then FC I can say lambda is 2 1. Okay, it means I have to find lambda F, and if I know AC, so that is lambda plus 1. So lambda is 2 1. Similarly, E divides BF in the ratio. So E is the bisected, it means AE and ED. So that is equal. Okay, so if this ratio we don't know, again we can assume this ratio is mu is to 1. It means BE mu EF, so that is 1. Okay, so now first assume the coordinates. Okay, so let's the coordinates of point B. I can say coordinate of point B. So we can assume B as origin. So for B coordinate 0. For vector A I can write A. For C I can write C. Now I can find position OD. So OD is equal to, so I know B, I know C, so OD, so D is equal to, or OD is equal to 0 plus C by 2. So I can say OD is equal to C by 2. Okay, OD is equal to C by 2. Okay, now I know coordinates of D or vector D and position vector A. So I can find position vector E. So position vector E is equal to, because it is 1, 1, because it is division ratio is 1, 1. Okay, so I can say D plus, so D is, that is C by 2 plus A. D plus A by 2. So I can say A by 2 plus C by 4. Okay, so A plus C by 2 divided by 2, because E is the midpoint of AD. So C by 4 plus A by 2. So now you know position vector. Now our aim is we want to find AF and FC. So AF and FC. So for AF and FC, so write the equation. So for point E, we know the position vector E. So for E, I can write the equation. So position vector OE is equal to mu into F. Position vector E is equal to mu into f, mu into f plus 1 into b plus 1 into b divided by mu plus 1. Okay, so mu into f plus 1 into b divided by mu plus 1. It means now I have to find position vector f. So now for position vector I can use this condition. So here it is lambda is to 1. So for f I can write, lambda into c. So lambda into c. So c is given, yes, lambda into c. So lambda c plus 1 into a. So lambda c a upon lambda plus 1. So lambda c plus a upon lambda plus 1. So replace f. So mu lambda c plus a upon lambda plus 1. So for b it is 0. So I can remove it. So divide it by 1 upon, or I can directly here write upon mu plus 1. So mu upon mu plus 1, lambda c plus a upon lambda plus 1. And this is equal to c by 2, sorry, a by 2 plus c by 4. Okay, so if I want to compare this, so one portion is c and second portion is a, so a by 2. So now a upon lambda plus 1, so I can write here mu upon mu plus 1 lambda plus 1 into a, okay, plus lambda into mu. So mu lambda upon mu plus 1 lambda plus 1 into c is equal to a by 2 plus c by 4. Okay, so mu lambda upon mu plus 1 lambda plus 1 into c, mu upon mu plus 1 lambda plus 1 into a is equal to a by 2 plus c by 4. Okay, so from this we can say mu upon mu plus 1 lambda plus 1 is equal to 1 by 2. So compare first portion and second portion, mu upon mu plus 1 lambda plus 1 is equal to 1 by 4. So I can write here mu upon mu plus 1 lambda plus 1 is equal to 1 by 2. And second, mu upon lambda, mu plus 1 lambda plus 1 is equal to 1 by 4. So if you look at mu upon mu plus 1 lambda plus 1, so mu upon mu plus 1 lambda plus 1, that is equal to 1 by 2, and into lambda is equal to 1 by 4. So I can say lambda is equal to 1 by 2. So mu upon mu plus 1 lambda plus 1, that is equal to 1 by 2. So 1 by 2 into lambda is equal to 1 by 4. So naturally lambda should be equal to 1 by 2. So lambda is equal to 1 by 2. So now you know the ratio, lambda is equal to 1 by 2. So 1 by 2 is to 1. So now I want to find AF and FC. So I can write AF upon AC. So AF upon AC. So that is equal to AF upon AC is AF plus FC. So AF is lambda, AF again lambda, FC is 1. So 1 by 2 upon 1 by 2 plus 1, 3 by 2. Okay, so answer is 1 upon, so answer is 1 upon. So you can see, so where we have started, so we have started with given position. Okay, so median is given. So first find out coordinate of D. Second, it is bisected. Bisected means equal portion. So use that condition. So E is equal to C by 2 plus A divided by 2. So A by 2 plus C by 2. Now you know the E. So assume lambda is to 1 and mu is to 1. So find out. So use this ratio, mu into F 1 upon B. Okay, and incorporate value of F. So you will get the answer. So now you can see mathematics is more complicated than physics as far as vector is concerned. Again, we have solved this example in physics. Okay, so sum of two forces is 18 Newton. Resultant whose direction is right angle to the smaller force. So I am giving you the shortcut directly. Suppose vector A and another vector that is B, and A plus B, so that is resultant is at right angle to smaller force. Suppose resultant vector R. So resultant vector R, that is equal to 12. Okay, so vector A and vector B, so this is your resultant vector, so naturally this is vector B. So vector A, vector B and A plus B, so that is equal to 12, and A plus B, that is again it is equal to 18. The magnitude of two forces, so again it is right angle triangle, so if result is this side is 12, the another side should be, so 12 6 is not possible, 14 plus 4 not possible, 11 7 not possible, so answer is only 13 and 5. So A is equal to 5 and B is equal to 13 and 5. Okay, otherwise you know R is equal to under root a square plus b square plus 2ab cos theta, cos tan alpha is equal to b sin theta upon a plus b cos theta. એ બધાનો યુઝ કરશું અને એક્ઝામ્પલ સોલ્વ થઈ જશે. અત્યારે આપણે અહીંયા ફિઝિક્સ કરતા આપણે મેથ્સ પોઈન્ટ ઓફ વ્યૂ જોઈએ તો આ કેવું શોર્ટકટ થી આ એક્ઝામ્પલ સોલ્વ. Now again, the length of longer diagonal of parallelogram constructed on 5a plus 2b a minus 3b. So one side of parallelogram. So one side is given 5a plus 2b and another side is that is a minus b. The length of longer diagonal of the parallel constructed when it is given that a is equal to 2 root 2, b is equal to 3 and angle between a and b that it is pi by 4. So a is given 2 root 2, b is given 3 and angle between a and b, so that is pi by 4. Angle between a and b is pi by 4. So find the length of two diagonal or length of longer diagonal. So we can say in the parallelogram there are two diagonal, one is d1 and second one is d2. So d1, so that is d1 is equal to a plus b. So a is the first vector, b is the second vector, so directly I can write 5a plus 2b, so that is vector a, plus a minus 3b, so that is first diagonal. I don't know whether it is maximum or minimum, so first diagonal that is a plus b, so 5 plus 1, so that is 6a, plus 2b minus 3b, so minus b. So first diagonal is 6a minus b. Second diagonal d2, so that is d2 is equal to a minus b. So first vector, so that is 5a plus 2b minus second vector, so that is a minus 3b. So I can say 5a minus a, so that is 4a. 2b minus minus plus, so that is 5b. So now from the figure we can say longer diagonal, so that is d2, not d1. Longer diagonal is 4a plus 5b, not 6a minus b. So we want to find the length of longer diagonal. Okay, so length of longer diagonal. So length of longer diagonal, so we know the value of mode of a, it means magnitude of a, not a. Okay, so for that magnitude of a, so we can say, so that is under root 4a whole square plus 5b whole square plus 2a b cos theta. So here length theta, so angle between a and b is given, so angle between a and b, so that is pi by 4. Okay, so whenever we construct parallelogram, so for longer diagonal, okay, so angle between a and b we have to consider. For shorter diagonal, we have to consider angle. So if this angle is, so angle between these two is external angle, so that is pi minus pi by 4. But for longer diagonal we have to consider cos pi by 4. Okay, so now I add the value. So 4a square. So 4a square, it means 16 into a square. So a is 2 root 2. So 2 square, 4 into 2. So that is 8. So 16 into 8. 5 square. So that is 25. And b square. So b square. So that is 25 into 9. Plus 2 into 4 into 2 root 2. 5 into b, so b is 3, and cos 45, so that is 1 upon root 2. So root 2 cancel. So here it is 16 into 8, so 144 plus 25, 9, 225 plus 15 into 2, 30 into 4, so 120. So 144 plus 225 plus, so final figure, that is 9. So naturally answer should be, so 5 plus 4, 9. So 360, not 369. So answer should be 593. So 4 plus 4. So here it is, here it should be 148. Okay. So 148 to 25. So answer is 593. There. So here you have to consider under root 4a square plus b square. So because 4a is one vector, 5b is another vector. So under 4a square plus 5a square. Okay. Plus 2ab cos theta. So 2ab cos theta. Angle between a and b. So that is given pi by 4. So that I have considered. Done. So now you can see the complication. The vector C directed along the internal bisector of angle between the vectors vector A and vector B. So vector A is given, vector B is given, and internal bisector. So internal bisector. So vector A, vector B, and suppose internal bisector. So that is C. Internal bisector C, where mode of C, so magnitude of C is given, so that is 5 root 6. Okay, so find out the vector C, find out vector C. So mode of C is given and find out C. So for any vector C, okay, so if you know the magnitude, so in the any vector, so there are two parts. One is magnitude and second one is direction. Magnitude and direction. So direction of this, that is internal bisector. So internal bisector, so that is A plus B. So instead of A, I can consider unit vector along A. I can consider unit vector along B. So I can say unit vector A cap, unit vector B cap, and A cap plus B cap. So that is direction. And magnitude, so we don't know exactly, so assume lambda, so scalar, so lambda is scalar into unit vector. So unit vector is vector A divided by mode of A. Similarly, vector B divided by mode of B. Okay, so direction into lambda, and that is mode of C. I can write that is equal to mode of C. Or so if I will remove the mode, then I can say C is equal to lambda into unit vector. Or I can say mode of C square. Later on we will do it. So now A upon mode of A. So mode of A is equal to, so I can write here lambda A. So A is 7i minus 4j minus 4k divided by mode of A. So under root 7 square plus 16 plus 16, so 32 plus 49, under root 32 plus 49, so 51 plus 30, 81, so directly I can write divide by 9, plus b, so b is minus 2i minus j minus or plus 2k, divide by minus 2i minus j plus 2k, divide by under root 4 plus 4 plus 1, so that is divide it by 3. Okay, and for simplification again divide both side, divide and multiply by 3. Okay, divide and multiply by 3, so easily we can simplify it. So now lambda, so 7i minus 6i, so that is I, minus 4j, okay, minus 4j minus 3j minus 4j minus 3j minus 7j, minus 4k plus 6k minus 4k plus 6k, so plus 2k, divide by 9, so that is equal to vector C. Okay, so now to calculate, so now mode of C is given, so mode of C is 5 root 6, so for that we can write, suppose I can write here, okay, mode of C square is equal to lambda into, so I can write 1 upon 81, 1 upon 81 into 1 plus 49 plus 2k, it means 4. Instead of lambda, I can say lambda square. So square both the sides. So magnitude mod of square C square lambda square 9. So that is 81. 1 plus 49 plus 4. So that is lambda square. And mod of C square is equal to 5 root 6 whole square. So 5 square 25 to 6. So I can say that is 150. So 150 into 81, 150 into 81 divided by 54, that is equal to lambda square. So 150 into 81 divided by 54, that is equal to lambda square. So when you divide it, you will get lambda is equal to plus or minus 15. Lambda is equal to plus or minus 15. Okay, so we want to find vector C. So vector C, okay, so vector C is equal to, so if I want to find vector C, then put lambda is equal to 15. So if I will place 15 here, okay, so divide it 3, divide, so 3 it means 5. So answer is plus or minus 5 by 3, I minus 7j plus a, plus or minus 5 by 3, I minus 7j plus. Okay, so what is given? We want to find vector C. So vector has two components. One is magnitude, second one is direction. So assume magnitude is lambda and direction, so that is along unit vector A and B. So A and B, so you will get unit vector. Okay, so now magnitude of C is given. So consider C square is equal to lambda square upon, so this you will get lambda. Put the lambda, so you will get the okay. So now in the next lecture, we will discuss linear combination of vectors. So thank you very much.